Dear students, today in this video I am going to discuss a topic from the inorganic chemistry and which is very important for the final year students, and the topic is silicones and phosphazenes. ओके अभी तक आपने अपनी लोअर क्लासेस में ऑर्गेनिक पॉलीमर्स के बारे में पढ़ा है, जो कि हम जानते हैं देयर आर मैक्रो मॉलिक्यूल्स ऑफ कार्बन एंड हाइड्रोजन with some other functionalities attached to them. Okay, whereas the inorganic polymers are basically more important as compared to the organic polymers. What is the reason behind this? This is because the inorganic polymers or inorganic based macromolecules, they provide the different combination of properties as compared to the carbon based polymers or organic polymers. Okay, what is the reason? The reason for the better properties of the inorganic polymers as compared to the organic polymers is that the bond between elements in inorganic polymers are longer, stronger, and thirdly they are resistance to the free radical reactions. क्या मतलब इसका मतलब ये है कि अगर हम ऑर्गेनिक एंड इनऑर्गेनिक पॉलीमर्स की फ्री रेडिकल रिएक्शंस को कंपेयर करें तो ऑर्गेनिक पॉलीमर्स जो है फ्री रेडिकल रिएक्शंस में क्लीव हो जाते हैं, सो दे आर नॉट क्लीव्ड इन दी फ्री रेडिकल रिएक्शंस, और यू कैन से दे आर रेजिस्टेंट टू द फ्री रेडिकल cleavage reactions. Okay, so from the inorganic polymers, silicones and phosphazenes, these two macromolecules, inorganic macromolecules or the inorganic polymers, are very important class of the polymers which have the very high, you can say, commercial importance. So what are silicones basically? So I am going to discuss first the silicones polymers. Okay, silicones क्या होते हैं? These are the polymeric organosilicones derivatives which contains the silicon oxygen silicon linkages. Okay, or they have alternate silicon and oxygen atoms in which silicon atoms are joined to the organic groups. Okay, So what is the general formula of these silicon polymers? It is R2SiON. ठीक है, क्यों? क्योंकि हमने यहाँ पे बताया है कि सिलिकॉन एटम्स आर ज्वाइंट टू दी ऑर्गेनिक ग्रुप्स, सो देयर विल बी आइदर 1, 2 और 3 organic molecules which are directly joined to the attached to the silicon atom. This is the general formula of the silicons, and this is the structure of the, or you can say, monomeric unit of the silicon polymers. These silicons are also known as the polyxyloxanes. Okay, so what are the characteristics properties? They may be linear, cyclic, or close linked polymeric structures. Okay, and the most important property is these are highly thermally stable. Okay, therefore they can also be called as the high temperature polymers. This is the main property of these silicons polymers, that they are better than that of the organic polymers. क्यों? क्योंकि ये polymers वहाँ यूज़ होते हैं जहाँ पे organic polymers को यूज़ नहीं किया जा सकता. Okay, because of this higher thermal stability of the silicon oxygen silicon atoms, these can be used in the high temperature processes. Okay, so next is the types of the silicons. There are basically 3 types. One is known as the silicon hydrides, which are generally known as the silanes. Second category is the hydroxy derivative of these silanes, okay, which are known as the silanols. And the third category is the oxo derivatives of silanes, which are known as the siloxanes. Okay, next is the nomenclature. First, I am discussing the nomenclature of silanes, or you can say silicon hydrides. So if the silicon is attached to the 4 hydrogen atoms, just like the methane, so they are simply known as the silanes, or silane simply is one molecule. Okay, if one hydrogen is substituted with the another molecule of silane, so this will be known as the disilane. Okay, and the 3 molecules are joined just like the propane, so 3 hydrogen will be there, 3 will be there and 2 hydrogen will be there. So this will be known as the trisilane. Okay, and if the 2 hydrogens are substituted with the methyl groups, then it will be known as the dimethyl silane. Okay, and if the hydrogens are substituted with the chlorine atoms, then these will be known as the dichlorosilanes. Okay, if we substitute these 2 hydrogens with the methyl groups, just like this, then this will be named as dimethyl silane. Okay, if we replace the hydrogens of the silicon with chlorine, 3 chlorines and 1 methyl group, then it will be known as the trichloromethyl silane. Okay, so next we have the silanols. In this case, if we substitute the one of the hydrogen of the silane with the OH group, that is like this, it will be simply known as the silanol. And if we substitute the 2 hydrogen atoms of the silanes with the 2 hydroxy groups, then it will be known as the silane diol. Okay, and this will be named as silane triol. And what would be the name of this molecule? This will be known as the trimethyl silanol. Trimethyl silanol. Okay, now if 2 molecules of the silanols, trihydroxysilanols, are joined like this, then it will be named as disilane hexol. Why so? Because there are 6 hydroxy groups and the 2 silanes, so it will be named as disilane hexol. Okay, next we have the siloxanes. Third category is the siloxanes. How could we name them? So this is the one example of the simple siloxane. So it is named as disiloxane. Okay, and this is known as the hexamethyl disiloxane. Hexamethyl disiloxane. Okay, and if this type of siloxanes will be there, then it will be known as the hexachlorodisilane. Hexachlorodisilane. Okay, next is the preparation of silicones. Preparation of silicones. Silicones are prepared by the hydrolysis of organochlorosilane. You may take the either alkyl substituted organochlorosilanes or aryl substituted chlorosilanes. The most important organochlorosilanes which is used for the synthesis of or the preparation of the silicones is the dialkyl dichlorosilane, and it is an extremely important compound because it provides the starting material for the preparation of wide variety of the substances, wide variety of substances or the polymers which are having the wide variety of the polymers. They are having the both organic and inorganic characters. Okay, so the simple hydrolysis of these dialkyl or diaryl dichlorosilanes with water in either acidic or basic medium leads to the formation of these. First of all, they will form the dihydroxy derivatives of organosilanes. Then these will, upon heating, polymerizes to inorganic polymers, that is known as the silicones. These alkyl or aryl substituted silicones halides which are required for the preparation of the silicones, they are further can be prepared by the main two methods. In the first method, you can treat the silicon tetrachloride or the tetrachlorosilane with the Grignard reagent, and it can form the alkyl tetrichlorosilicones and magnesium chloride which will be settled down. Similarly, these trichlorosilane can further made to react with the Grignard reagent, and it leads to the formation of dialkyl dichlorosilanes, which are very important compounds required for the preparation of the silicones. Okay, so by this method a wide variety of substituted chlorosilanes can be prepared by reacting with the Grignard reagent. For example, if you further made to react this dialkyl silane with the Grignard reagent, then it will lead to the formation of trialkyl chlorosilane and magnesium chloride. Okay, on further reaction of trialkyl chlorosilane with Grignard reagent, again can form the tetraalkyl silanes. Okay, so the process becomes very complicated. Why so? Because we also need to prepare this Grignard reagent freshly while carrying out the reactions. Okay, so this Grignard reagent can also be prepared by the reaction of alkyl halides with magnesium in the dry ether, and it will lead to the formation of Grignard reagent. Okay, so this in situ prepared Grignard reagent, or you can say freshly prepared Grignard reagents, is made to react with the silicon tetrachloride. Okay, so the second method, which is advanced than this method, is known as the Mueller-Rochow method, or process. Why so? Because in this method or in this process, simply any alkyl halide or alkyl chloride is reacted with the elemental silicon in the presence of a copper, which is acting as a catalyst at 250 to 550 degrees Celsius. It leads to the formation of organohalosilins. Okay. For example, if we react the silicon with 2 molecules of alkyl chloride at 250 to 550 degrees Celsius in the presence of copper, then it will leads to the formation of dialkyl dichlorosilane. Okay. In this process, some of the monochlorosilane and trichlorosilane, this is the trichlorosilane and this is the monochlorosilane, can also be produced as a byproduct, which can easily be removed by the simple distillation. Okay, these byproduct can made to react with each other at 400 degrees Celsius in the presence of anhydrous aluminum trichloride, which is acting as a catalyst in this reaction. So these two byproducts can react with each other and they may lead to the formation of dialkyl dichlorosilanes. Okay. Now, as I earlier said that upon hydrolysis, these dialkyl dichlorosilanes in the acidic or basic condition at a different temperature, they may lead to the formation of dialkyl silanols, okay, which upon heating they get polymerized and form the silicones. Okay, so there is a very interesting point here that under basic condition, or you can say the base which is acting as a catalyst in this reaction, under basic condition and high temperature leads to the formation of linear and high molecular weight polymers, whereas under acidic conditions it favors the formation of cyclic and low molecular weight polymers. Okay, so what happened? As I said, initially the organochlorosilanes, they react with water and leads to the formation of dialkyl silanols, which upon heating they form the silicon polymers. How this reaction actually occurs, I am going to write here. Initially, the two molecules of dialkyl silanols, which are having the active OH group on the both sides, the two molecules initially reacts by the elimination of one water molecule, and they form a dimer like this. Okay, because this dimer again have the OH group on the extreme ends, so they further react and form by the elimination of water, they form the polymeric molecules. So I'm going to write here the silicon, oxygen, silicon, oxygen, silicon, oxygen, silicon, oxygen, silicon, oxygen, and so on. Here also it is going to react and forming the linear chain polymers. Okay, now next is the formation of crossed links silicones. For the formation of cross-linked silicones, we require the trichloroalkyl silanes, or you can say the alkyl trichlorosilanes, which upon hydrolysis first it forms the alkyl silanols, trihydroxysilanols, and with the removal of 3 molecules of HCl. Now these trihydroxyalkyl silane, they further react and with the elimination of water molecules, just like this, first they form the linear chain silicon polymers with the elimination of water molecules. It leads to the formation of here we have the OH groups. Here we have the R groups. Okay, so what is going to happen? So these linear chain silicones, which are again having the OH group on the upper side, they react or polymerize, or you can say they get cross-linked and form this type of structure here. Or they may have the alternate R groups. Here it is having the O group. Okay, so it is having R group, it is having R group, it is again having the oxygen here. So this type of cross-linking is possible in these molecules, so they form the cross-linked polymers. In the next video I will discuss the various kind of the commercially important organosilicones and the rest of the topic, that is the polyphosphazenes. Thanks for watching.